Hi, I'm Akshat Verma, and essentially I'm going to talk about system design. Now, system design is a topic that has been close to my heart for the 22 years essentially that I've worked in the industry across various aspects of distributed systems, even while building systems, cloud systems, while building essentially e-commerce systems that make my trip, or while building various kind of digital systems essentially at Airtel and at other places. So system design is fundamental. This is what separates a developer from a principal engineer or an architect. A lot of developers have seen essentially struggle to go beyond a certain level in their organization. And I think one of the most fundamental reason why they struggle and essentially hit this ceiling is because they cannot design a system end to end. I think that anyone who has the right attitude is willing to put the hard work and actually learn system design and basically cross that chasm from a developer to an architect. So system design, if you look at it, right, it fundamentally there are four different things that you essentially tend to do when you're building a system end to end. First thing is essentially you take a large abstract platform or a product problem and break it into small functional components. And the magic here is the way you break this component so that every component does one thing and does that very well, so that you can go and extend one component without touching other things. The next step is essentially to make the technology selection for each component. So if you have a component that requires a caching layer, requires a database, requires a compute layer, what do you use? Do you use a Lambda function for your compute? Or do you actually host it on a Tomcat as a web application? Do you use a Mongo or a Dynamo or a MySQL or a Postgres for your database? What caching layer do you use? So those are the kind of choices you need to make in tech selection. And then you need to communicate your components and your tech choices in a succinct fashion, capturing the most important decisions and their rationale. Document cannot be so large that no one wants to read it. So you have to strike the right balance. Finally, right, what you need to do is you need to make sure that your application will work with the right operational performance that you want. And their choices around essentially latency versus durability. How many replicas should write or persist the data in storage before you essentially acknowledge. So choices between consistency and partition. So those are the kind of choices you make in terms of the operational design. So what I'm going to talk primarily in this course is essentially about functional design. And all four are important, but arguably this is probably the most important aspect of system design that everyone should be well versed in if they want to be an architect. So if you look at functional design, what exactly is it? Functional design is nothing else but the ability to break a large problem into small parts so that each part is independent or almost independent of other parts. So your components, essentially what you build at the end of your functional design. And it's the way you build those components. Essentially, you start with understanding what are the core functions that your users do. Based on those core functions, you're essentially going to design your component one core function at a time. When you look at one core function and you want to design the components for it, you just first need to figure out what are the concepts or the data model that drive that function. And then you're essentially going to break your concepts into clusters such that each cluster takes responsibility for only a few concepts. And those concepts need to like couple together well, and they should be independent of other concepts. And you essentially need to do it in a way that there are not too many components. I mean, so microservices leads can lead to like service sprawl if you essentially try to partition and partition and partition. So again, there's a right balance that you need to build as far as your components are concerned. Just designing your components is not enough. The components need to integrate with each other. They need to integrate with the front end. So essentially, you need to look at things like how do you make sure that your front end and your back end can evolve independent of each other. Look at solutions like building a separate backend for front end layer. You look at things like, should I just use GraphQL as my backend for front end so that essentially my backend can evolve independent of my front end? And finally, right, You build your components, you design them, but you still need to look at the system end to end. You need to bring all of this together. That's what we call end to end view or harmonization. So you need to essentially make sure how is data flowing through your components. Are you keeping the right copies of data, right? So you can, if you start to have like multiple copies of data, then you will have data sync problems. How do you look at those things? If you actually need to replicate the data, what kind of replication mechanism do you need to employ? So those are the kind of things when you essentially look at all of these components together and look at the big picture and make sure the big picture is still accurate. So that's essentially what functional design is all about and what we're essentially going to cover in a lot more detail in the course. But I think this gives you good flavor of what all aspects are needed to essentially take an abstract problem and create small components that essentially execute specific functions, but you still get in an end-to-end view the entire product or platform that you want to build.